This presentation is, let me get rid of this jacket. This presentation is to show you a neat little piece of software I discovered while messing with the PICAXE controllers. It's called PEBBLE. It's basically a solderless breadboard emulation package, is what it is. And it is browser based. This is what it looks like when you see people doing pictures when they do a article or something and they do a captures. This application can really help if you want to show off what you've developed. How many of you use solderless breadboard? Played with them? Okay, great. So you don't need an introduction to what it is. But breadboard's really nice. The only downside is you only work with low frequency stuff mostly because there's long wires and plenty of capacitance, so they're not very good for high frequency work. So, but really great for low frequency stuff or working with microcontrollers and regular integrated circuits and standard components. You also will find these things pretty handy if you want to develop something and you can't do the miniature stuff like they're using today. You know, using tweezers to put parts on a board is just not my idea of fun. We have a little list of the things that you can do with the solderless breadboard. Prototyping, you can lay out circuits pretty fast. I don't know if you guys remember in the old days, we had something called wire wrap. Was a real pain to work with. It worked, but it was really a pain. Here you just stick parts in the holes and off you go. Handy for learning electronics or refreshing your memory on how a circuit works like a transistor. You can rearrange components. If you design something, you can rearrange the components here and then in the application, and then transfer your changes to your actual solderless breadboard and make quick changes for errors and hookups or whatever. If you use a component you've not used before, like a MOSFET or something, it's pretty handy for using it as a learning tool. And sensor interfaces. This is really ties in with the microcontrollers because there's a gazillion different kind of sensors available now. Heat sensors, temperature sensors, or RFID, ultrasonic, infrared, and just all kinds of stuff you could hook up to these microcontrollers and play with now. Most important thing though is the solderless breadboard is not for permanent circuits. Actually, we're going to get around that a little bit later. But that basically you build up a circuit and then you tear it down and build something else. This is what the solderless breadboard, in fact the term breadboard, that's what it means. It's just building it on a board and going with it. These breadboards or solderless breadboards have power rails on them. There's different kinds. I did not buy any that did not have what I'm going to be using in the example, but some of them have one power rail or even no power rails. But the ones I bought ever since I started buying them have two power rails on the bottom, two on the bottom, one plus and one minus. And normally it's marked with a red and blue line on the solderless breadboard. Connection points. When you use the solderless breadboard, those little 5-pin or 5-hole strips are all connected together. So sometimes you have to be a little bit careful about plugging stuff in. You may plug it into something that's already hooked up to a pin somewhere else, thinking you have a loose or have an open connection there, but you may not. this is really important. This application is not limited to just PICAXE projects. If you work with any type of IC or any other type of controller, you can use the Solidus breadboard. I work with quite a few different controllers. I like the PICAXE. For one, it's real cheap, and two, it's real easy to work with, and the programs are basic. But there's other controllers that you can buy that will plug into the board. You can also use this thing to design modules for reuse. One specific example would be like the connector that connects to the PICAXE is a micro phono connector. That connector has a particular pin out, so you use a receptacle and run 3 wires over to your PICAXE, and they have to go through a couple of resistors in one case, but you can set up a little sideboard and have this thing develop, or have this thing built for you. Screen capture. If you're using a Windows PC, Windows 10 later, the Windows key, Shift S, will turn on a thing called the Snippy tool, which I use a lot. I also work with desktop lasers and applications, so I do a lot of online with the BreadBoard, and I use the screen capture a lot. And then there's the part where I said you're not permanent. It is. It can be. I buy little breadboard, circuit boards that are same design and even the same labels as the Solidus breadboard. You can buy them as little PC boards and put your parts in them. What you see in this image is a ZIF, zero insertion force socket, which I bought some of to put parts in and out. If I fry one of the PICAXE chips or something else, I can unplug it real quick and pop a new one in. So anyway, a ZIF socket also happens to fit right across the pins pretty well. And then I found one of these at one of the flea markets, ham flea markets. It's a Radio Shack board with a couple of a whole section of board and terminals. You see the connector on the side, the 3 wires, that's the input for the PICAXE. And here's the Solidus breadboards with the solder breadboards. You can see you can buy either full size or half size. If you have a small project that doesn't take up much space, why waste the whole breadboard? You can buy the half size. And you can see they're even numbered rows and columns, just like the full-size breadboard. And you can see they're also the same size as a Solidus breadboard. So everything translates 1 to 1. Unplug it off the Solidus, plug it into this guy, and solder it. One of my circuits, designed but I haven't built yet, is a little thing to signal UFOs. Now, I got this idea. I put a laser in a box with a window in it outside, and at nighttime have this thing come on and start sending pulses of light, beams of light from a laser at a slow rate and using prime numbers. So I figure if a UFO flies over, if they see a light flashing prime numbers, that means something close to intelligence. This is where I use the board. I did build a board with the resistors on it and the phono connector, and unfortunately it dawned on me afterwards that I have to have those 2 resistors on the PICAXE board for it to work. In other words, a 33 ohm, or 32 ohm or 33 ohm resistor between 2 pins on the PICAXE is required. And I don't know why they designed it that way. So now my circuit board or sideboard is just a connector and something with some long wires on it, so I can run them over to the solderless breadboard. And this is the 2 resistors that have to be on the board. Another application, and this thing can be adapted to position an antenna, like for satellite tracking. You can change the speed of it. But this was a solar tracker circuit that I found in, I think, one of the Instructables. And it actually controls a stepper motor, you know, servo or stepper motor. And you can see something like this, but we be well suited to put together on a solderless breadboard to prototype it. Okay, the PEBBLE application has a gazillion board designs in it. I didn't realize there were so many on the solderless breadboards. You can buy a lot of different ones. And there's probably anywhere between 20 and 50 in the list. I never looked at it. But I had trouble finding the one I needed. Let me go back. I had trouble finding the one I needed because my solderless breadboards are all 60 pin. There were 60 rows or columns, depending on how you look at the board. But the maximum on the PEBBLE application is 50. And I don't know how to go in and change it in the PEBBLE application, because the PEBBLE is an XML program. So you can, it's a JavaScript program. So you can go in and change it, but I'm not a very good JavaScript programmer. But I don't know why they did not add 60, because every solderless breadboard I've purchased since I started messing with those things has been 60 rows. You can see here a lot of choices for the ICs, you know, 8 pin, 14 pin, 20, 30, even 40 pin ICs. So you can pretty much play with anything you want to work with. This is a simple strobe circuit I just saw somewhere. And it's supposed to be something where you push a button to speed the blink rate up and push the other button to slow it down. And it uses a couple of LEDs for your strobe. And I have not actually built this thing, so I don't know how well it works. But I expect you would need to use large LEDs to get any decent light out of it. The cheap PICAXE, the 08M2, is the $3 one. But if you need more pins, you can use the 14. I started out with this application, or developed this presentation, and was using 08, and then I realized my circuit diagram that I'll be working with was the 14M2. So I had to go back and change some of the pictures and stuff that I captured. But you can see either one is pretty cheap. Oh, and what I meant to say here also is that the program code will be the same between the two processors. The only difference will be your pin assignments. For example, there is no B pin assignments on the M8 or M08 and M2. When you're using the solderless breadboard, you place the big stuff first, which is what you should do if you're using the breadboard. And same thing with this application. Put your big parts on there first so you can move stuff or put other stuff around them. Then you add your smaller parts and check your work. And this is where you get to move stuff around so it fits. and then you add your jumpers. These jumpers are interesting, and later I'm going to be doing an actual presentation of doing this on the screen. But the jumpers, you can put jumpers over top of each other. For example, if you see right under the switchers, there's two little short jumpers there. If you put a tube hole jumper in there, it'll just go from the bottom of one switch to the bottom of the other switch, and it will not indicate that there's a pin. So you use two short jumpers, so when you look at it, you see that actually all three pins are connected together. And this is important. PEBBLE is a browser program. Okay, you're using your Windows Explorer, Chrome or whatever, using your browser. You click on the Save or Load button, and you'll get a screen of a bunch of stuff. And basically, that stuff is what PEBBLE is saving as it's building the drawing. You copy the text to a file and save that text somewhere that you can find later. And when you close the browser, your long and hard work is not saved. And it says, ask about the oops. Yeah. When you reload your work, you click on the load button, or click on the save or load button, and then go get your text file and open it up, copy the text out of that file, and drop it into this window. And then at the bottom, you click on load circuit. That's where sometimes you might say, okay, I'll close the window and it's done, but it actually has to tell the browser what code to run in the JavaScript. PICAXE cable. I had to put drawings and stuff all over the place so I remember what is what on these. But basically, pins 3, 2, and 1 in the drawings are the tip, ring, and sleeve pins. You build your circuit, you put it together, it's on the breadboard. Although we're doing it here in the screen as development, but transfer or put all your parts in your breadboard, apply power to the rails and turn it on and see what happens. This is part of a sample program, a PICAXE program. You run your program, and if something's wrong or screwed up, just simply go back into your drawing, move your parts, because you may have to move things around to get the new part to fit, or the missing part, or the part that's in the wrong place to get it in the right place. So you just basically transfer, go back and forth between your development screen and your actual breadboard. This particular application uses buttons, but if you can program the PICAXE, you can also go in and set up for using a potentiometer to vary the speed, which makes a lot more sense than pushing a speed up, speed down button. Because with a speed up, speed down button, you're limited to whatever step interval is in the program. In other words, you can go up 10 pulses per minute, and your next step might be 15. With a potentiometer, you can split the difference. So you'll have a continuous adjustment rather than discrete steps. Here's a list of useful links. PICAXE manuals. If you program in a PICAXE, there's 5 manuals, but the real important one is number 2. Number 2 is the program code. That's basically the how-to book. if you're not a programmer, but you want to play with a microprocessor, PICAXE is a good place to start. And Education Revolution, I think that's their proper name, makes the PICAXE. They give you free software to do stuff. PEBBLE was developed by somebody else, but then Google developed Blockly, and then applied it set it up for the PICAXE controller. So you can actually program the controller and create the code and not be a programmer, which is pretty good. This thing takes this controller, programming the controller, down to probably 7th grade level. And my name is Mike Hembry, call sign KV0OOM. That's also the license plate on my car, which the license plate KV0OOM's on the back of a Corvette, so everybody loves it. And like I said, electronics, I've been in electronics since, actually working with electronics since 1962. That's when I built my first radio, or took my first radio neighbor gave to me, and replaced a couple of tubes and got it working. It was a little tabletop, no transformer radio, and yeah, 5-tube vacuum tube radio. Yeah, and I got it working, and I thought success, and that's how my career got started. Also, my career almost ended when I had the radio in the garage, and I sat it on the concrete shelf in a window in the garage in my dad's house. And when I sat it on the shelf, I touched the 4 screws on the bottom, which went into the chassis, and it's a direct hot chassis on the radio. It was a transformerless radio, one of the ones that were direct. And I dropped the radio. Unfortunately, it did not break. I was not broke, so my career kept going. But that taught me a valuable lesson. Electricity is not fun to play with. It's only fun to play with if it's not you. Thank you for attending the presentation. Any questions?
Does PEBBLE emulate op-amps?
Good question. Let's go in and actually run PEBBLE.
Okay.
We're done with that presentation, so.
Because I'm thinking in terms of filters and stuff like that, active filters.
On the screen on the left-hand side is a list of the things you can use. If you go into put an IC in and right-click on it, you can pick your chip. But then you can go down and see all kinds of stuff.
Oh, okay.
How about a 74 AC 196 4-bit shift relay or shift register? I believe that's what that is. Or this list is quite long.
I see Macs there. I see CMOS stuff.
Yeah, let's pick something a little strange. How about the quad analog switch? Oh, no, that's not. So what I want. Okay, generic 8-pin op-amp, or how about a CA3140 op-amp?
3140 will work.
Okay, so now we have an op-amp.
Okay.
Now you can place it anywhere you want. Basically, you have to straddle that white strip in the middle, because all the pins on one side or the other, they're all connected in a row. But you can move the part around. Now, oh, by the way, you see the notch is on the left-hand side?
Pin 1 is.
Okay.
Nice.
Go in, little radio button, click OK, and it moves it to the other side. Okay. This application is really pretty decent. and a lot of fun to play with. Here's an LED. But you have a choice of colors. In this application, I used red because, like yellow, is hard to see, and white is almost impossible. You only see white only because it covers that part of the pinholes. So I just stuck with red for everything.
The building we're in, I think they prefer red and blue.
Yeah. Blue we got. We need it.
Okay, so I see the N plus and the N minus and the out, okay.
Uh-huh.
Yeah, where's the ground?
I forgot to do something. Let's see, it'll probably wipe everything out, but
Okay.
I forgot to go in and select my breadboard.
I'm already digging this though.
Somewhere it is. There we go. That's the one I want.
Hey, kept everything in it.
Good. I like that. I didn't know I could do that. Anyway, you select your solderless breadboard type and then start putting parts on it, not exactly the way order I did it. Oh, you can, you see what I added here was a little black 3-pin header. You know, this is a little guy you stick in and it has the pin sticking up. Okay, but let's see what else that can be. Let's pick, let's make it a screw terminal. And I want the, let's see if it turns screws. Okay, it's got the screws in the right place. Now, one thing about the screw terminal is it skips a row. If you look at it, you can see that there's a row between these that's not hooked up. They go one, skip one, then one, so on. So those rows are available to use for something else for jumpers. You can move it around, or you can actually increase it to a 6-pin. You're going to have fun. If you use this application, PEBBLE, you're going to have fun playing with it and probably not get any work done.
I have radios next to my own computer at work, so I already don't get enough done.
You can also add comments.
Is this a separate program for PICAXE, or is it in the PICAXE program?
No, this is not included with PICAXE. PEBBLE is separate.
Separate?
Yeah, and it's basically it's a application. It's a browser application that you can download and run standalone. You don't have to hook up to the internet once you download it. In fact, if you see up here in that address line, it's HTML, it's a file. I'm running on my C drive, and you can see over here on the left-hand side that I'm actually in a browser. I think the shortcuts for starting this thing say FF and MS or something, or EX, but it's for Firefox and Windows Explorer. but it works in the Google
Way to find
application.
out all the things that don't work.
Sorry?
It's a great way to find out all the things that don't work.
Yeah, yeah,
Well, before they blow stuff up, too.
yeah. Well, fortunately,
Find what
you're only working with 5 or 12 volts, and it's probably current limiting source, like wall warts. So you probably won't create too much smoke if you wire something up wrong.
I don't know, there's still something interesting about having a transistor whizzing by your
Yeah.
right ears. It's trying to, even though we're
Yeah.
in orbit.
I had a meter that I hooked up wrong at one time. I had it on the current range. It was supposed to be on the voltage range, and I wasn't paying attention. And the meter blew up, and I tasted copper for 2 days. Let's throw in a couple of jumpers. Oh, wait a minute. I was going to talk about labels. Well, they didn't come out as large as I thought. The label says hot with exclamation point, but it's not very big. So I thought it would fill up the whole text box, but it did not. There's nothing here to set the size of the text. That's interesting. It centered it in the arrow type box, but not the bigger one. Let's put a diode in here. Somebody pick a diode type.
914.
Yeah. I don't know if you can see it or not, but it actually put on the diode the 1N914 that I put in the little text box. Can you see that out there? Oh, you don't have your glasses on.
It wouldn't work that far anyway.
Yeah.
I can't hear, can't see. They still give me my license.
Yeah. Yeah, as long as I can fit my Corvette, I'm not giving up. What else can we play with here?
I believe you'll be able to run that on Linux too, since you're running it in the browser.
Yeah.
And Chrome supports JavaScript natively. Not sure if you can run it in iOS. You'll have to probably use Linux shell.
Yeah.
Pain in the ass.
Well, anything iOS related is usually a pain in the butt.
Anything involving Apple's a pain in the butt.
Okay. Save or lost. There's all the gobbledygook I was talking about. That actually looks like a CSV file. But anyway, you copy it and you paste it into a text file, and then later you click, when you bring it back in, you paste it here, and then click on load circuit, and it will say, if you have something that's different, then it'll clear it. So you might want to save your work before you start or bring in a different project. On the jumpers, you have lots of choices of color. over here you see a span is up to 35 pins jumpers. That's a long ways down that board with the jumper wire. You also set it either horizontal or vertical. Let's see what else. Oh, I didn't know you could do this. You can also space it above or below the line. Let's make it brown so we can see it easy. So you actually put one jumper underneath it and offset the jumper on top of it and see both of them. So that's a nice little feature too. Any questions? Well, that ran longer than I expected.
I think it's just cool. As long as I can emulate some common op amps and some common ICs,
Yeah.
I'm gonna be a happy camper.
Well, it's a great program.
It'll be
I had
a
some.
lot easier using OrCAD and Spice.
Yeah, I had some. Oh, by the way, when you put a resistor on, it even color codes the resistor in the drawing for you. So when you put a value in, or you select the value on the resistors, and it actually color coded. Let's put a couple in just to show that.
Does it do that for inductors or capacitors?
I have no idea.
Okay. I ask crazy questions.
Yeah, here's a capacitor. I think that's what it is. Let's see. Let's mouse over. I thought it would tell me what it is. Okay, here's a resistor. Let's change the value from, it has all the standard looks like 5% values, 470 ohm resistor. And you see the color pattern changed on it.
And you didn't get squat with that capacitor. I'm surprised it didn't at least tell you a value.
Value. Okay. Here, this one you.
Yeah,
Yeah.
I know.
Yeah, because apparently there's not standard value capacitors, although I usually get a box of them with standard values.
Tell you what, try a disc capacitor and put in 0.01 microfarad and see what that does. See if we get the 10.4 on it.
Let's make it a medium size so we can see it. Okay, puts the value right on the part.
Okay. Yeah.
Yeah.
John's thinking the way I am. We're lazy.
Let's make it.
Well, what happens when you're doing this stuff is you change this one out, put that in, you're trying to follow something, but you forget to write it down, and then it finally works, and you can't remember what the heck you did.
And then you're like, oh
Yeah.
shit, I gotta measure the values of each part.
Yeah.
That's really neat. How long has this been out?
I have no idea. I discovered it last year. In fact, I discovered it right before TECHCON, last year's TECHCON.
I can't wait to teach electronics to the beginners at Tampa ARC with this.
Oh yeah.
Because I think Dave Birnbaum and I are going to have a field day with it.
Yeah, I'm surprised that, especially so many talks here about the PICAXE, because Daryl's been doing it, that nobody mentioned this one, this particular program. Let's see what would happen.
You got switches, and I'm willing to bet that if you click on the switch, then you have different options for that too.
There. The bigger capacitors start spanning more holes.
Okay, that makes sense.
But you can read it now.
Yeah.
I hate to think what the print looked like on the smallest one.
Yeah, imagine putting a full
Switches.
IQ on there.
Let's put a switch. We have choices between toggles.
Okay.
let's make it a toggle switch. Set vertical. And red, green, and gray. Oh, here we go. Yellow, green, and black.
It's SP, ST, or SPDT only, so. Yeah,
Yeah, I don't think this goes into multi-gang switches.
yeah. I was hoping that rotary switches would be an option.
I thought I saw rotary switch somewhere. Let me close this, see what this one does.
It's rotary, there we go.
There's rotary. What else you want? We're on a roll.
Tubes.
We're on a roll.
Tubes, we want
Yeah.
5U4.
Yeah, what do you want the tubes for? To prop the breadboard up?
Actually, they do make breadboards for, I have seen breadboards for tubes that can handle like your typical AA5 type tubes.
Is the AA5 like a 12-volt tube?
AA5 is the tubes, is that common AM radio configuration,
Yeah.
you know, with a 3.5C5 as the, a 5.0C5 as the final amp, and a 3.5W4 as the rectifier, you know.
Yeah.
So it can handle tubes like those. Obviously, you're not going to stick an 811A on or
Yeah.
an 813,
Yeah.
you know, on these breadboards. But they handle low voltage tubes, and a lot of tubes can be run at low voltage. 12AX 7As will run with 12 to 24 volts in the plate.
Proto parts and edits. I have not played with the thing enough to know what this is. Oh. That little guy right there is interesting, because you can take one of these breadboards apart and cut some of these strips.
Yeah.
You know, take a pair of snips and snip it, and it makes like two sections. So you can have, for example, 2 and
2 more.
yeah, only let's make this in a different color and span of 1. So you can make it like that, where this is conductive and this is conductive, and they're separate. So, but you'd have to put dots or something on your board to remember where those guys are.
So can you add parts? In other words, can you go into will it allow you to say, hey, I have SA612 or an NE602. Will it allow you to add the specs for that part in
Okay.
there? Say, oh, okay, this is a Gilbert cell circuit.
Yeah. Let me answer your question with a question. How much did this cost?
Free.
Okay.
So the answer is probably no.
Yeah, exactly. If
Yeah,
you're,
unless you know
if you're,
JavaScript
yeah, unless you're a
real well.
JavaScript or programmer that can wade through JavaScript, you can add stuff. But I looked at it and I says, not worth my time. So, but if somebody's a true JavaScript programmer, they could probably wade through it pretty quick and find all the connecting pieces.
It's just a badass program.
Yeah, and it's based on basically JavaScript and lots of images. So all these parts are actually images. Every one is a different image.
And it looks like I see a transistor there. I'm willing to bet if we click on it, we'll find out that it'll do FETs, bipolars.
You can even do optocouplers, that's
Yeah.
in the list, yeah. Like a 6-pin optocoupler, 555 timers already.
Oh, yeah. You
How
gotta
about,
have
how about a
455.
speech synthesizer?
Oh, yeah, I've seen those. Those are
Yeah,
badass.
only you can't buy them now, they're obsolete.
Yeah.
And if you can buy them, they're like $70. I already checked into it. And you can get a Votrax SC01. The Votrax is probably the best one I've seen.
I saw one that has 11 different messages up to 20 seconds long.
Yeah,
And I'm thinking, there's your contest voice keyer from hell.
yeah, yeah, really. Yeah, just use your little rotary switch here.
Yeah. Well, or just have a button that when you press the button,
Yeah.
it sends that message.
Yeah,
You know, so you can have all the comments.
one button for each message.
Then you can have one that says, "Look at the jackass, I've had this frequency, the
Yeah.
big red button for the last hour and a half. Go away."
Yeah. Yeah, there's still some C beers in ham radio.
You know, yeah. If I'm at the Tampa Club and I'm on 40 meters, I've got two elements at 120 feet and 1,300 watts. I can kind of tell
Okay.
them to go away and they'll go away.
All right. I guess because our technician is here, that concludes our presentation.
Well, if you still
Or-
have more